Okay, today we shall be doing the vector error correction model, and that is and here are the data. We have the three variables, and these are the time series data. I am opening all the variable as a group, so you can see the data x1, x2, and y. And the data and the variable start from 1960 until 1990. You can see all the data, all the variable of this model. So our task today we shall be developing a vector error correction model, meaning that VECM model. Okay, what is our assumptions? Suppose we assume that all the three variables will become stationary after first difference. Suppose we assume that, but we have not tested yet, or we have no plan to test it here, but we assume that x1, x2, and y, these three variables become stationary after first difference, because what is happening in the VECM model, the variable must be stationary. That is the important in VECM model. That means in the VECM model, variable must be stationary, and if it is not stationary, our task is to make it stationary first, then only we can run the VECM model. And as I said, here we assume that these three variables become stationary after first difference. Okay, now and also there is one more thing. If the three variables such as x1, x2, and y, if these three variables become cointegrated, only then we can run VECM model. And if they are not cointegrated, we cannot run VECM model, right? So that is also another important thing in VECM model. Okay, first I check whether these three variables are cointegrated or not, as before. And what I do here, how to check the cointegration. So actually all these things I discussed in another video. I'm going to click, then going to group statistics, and here Hossain test of cointegration, that I shall be choosing to check whether our three variables are cointegrated or not. Okay, here I'm putting all the variable y, x1, and x2. Right, I mentioned three variables here. Then I press OK. Okay, so here suppose there is only one lag. Okay, I keep it as it is, and here I choose number 3. Why? Because I assume that our data has a trend. So I take the number 3, and it is lag 1. Then I press OK. So the outcome is coming. Okay, the outcome has come. So you see there is the trace statistics here, and here is max IGN statistics is here. So from here it is the null hypothesis. What is the null? meaning that there is no cointegration. So this is the null hypothesis. So I can reject the null hypothesis. Why? Because p-value is less than 5%. So I can reject the null hypothesis that there is no cointegrations. Okay, then it is the second null hypothesis. What is it? At most one cointegrated equation exists. So this is the null hypothesis. Can I reject? Yes, I can reject it because the p-value is 1.78%, which is less than 5%. So we can reject the null hypothesis. Then what about the last one? What is this one? The null hypothesis is there is at most two cointegrated equations. So can I reject it? I check here. What is the p-value? Probability value 8.38%, which is more than 5%. So we cannot reject null. Rather, we accept null, meaning that there is two cointegrated equations. That means all the three variables such as y, x1 and x2, they are cointegrated. That means they have long run associationship, or in the long run these three variables such as y1, such as y, x1 and x2 move together. That is the decision under trace statistics. And also you can see the result here. Trace statistics indicates two cointegrated equations. Then I check the second test, max eigen statistics, right? Okay, it is the null hypothesis, number of cointegrated equation. It is the none. None means there is no cointegrated equation. That is the null hypothesis. So can I reject or accept? So probability how much? The probability is 0.02%, which is less than 5%. So we can reject null hypothesis. What is the guideline? As I said in my previous videos, that if the p-value is less than 5%, we reject null hypothesis. And if the p-value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. Okay, then I come here, the second one, at most one, meaning that there is at most one cointegrated equation exists. This is the null hypothesis. Can I reject this null hypothesis? You come here. What is the p-value? 3.330%, which is less than 5%, meaning that we can reject this null hypothesis. Then we proceed. At most 2. Can I reject that there is two cointegrated equation in the whole system? Can I reject? No, because we cannot reject, because the p-value is 8.38%, which is more than 5%. So we cannot reject null. Rather, we accept null, meaning that there are two cointegrated equations in the system. That means our three variables such as y, x1 and x2 has long run associationship, or they move together in the long run. Okay. And you can see also it is mentioned here, max eigenvalue test indicates two co-integrated equation at 5% level. Okay, what is our decision? Using test statistics, there are two co-integrated equations. Using max eigen statistics, there are also two co-integrated equations, meaning that these three variables are co-integrated. So, and when the variables are co-integrated, we can run the vector error correction model. So that we want to do now. Okay, how to run the vector error correction model, that we can do now. How to proceed? I go to quick. Okay, here one thing, make sure. Okay, I proceed. Quick, then estimate var. I click, and here I write y, x1 and x2. You see, I write three variables, and you know, as I told you before, and then I choose here vector error correction model. That I also choose here, right? Because our three variables are co-integrated. Okay. And you know, as I told you before, that vector error correction model require that the variable should be stationary. And I told before that why our variables become stationary after first difference. That I told already. And you know what happens in the VECM model? So VECM automatically make the variable first difference. VECM automatically convert the variable into first difference. So meaning that here I put y, this y will become dy. Here I put x1, x1 will become dx1 automatically. That the VECM model or our software that we are using, which is EVIEWS, she will do it for us automatically. So here I am putting our variable at the label form, and our software will make it first difference automatically. So we don't need to worry about it. Okay, so this is our setting so far. Okay, then we are talking about. Okay, here we have chosen 2 lakhs. It is already given, so it is there. And now we need to talk about co-integration. That I click here, the co-integration, right? And you know, here is mentioned number of co-integrating equation that we need. Here mentioned 1, right? But actually we need two co-integrated equation, not 1, because we have just seen we need the 2 co-integrated equation. So I put here 2. I put here 2. And I also keep it 3 because I believe that, or we believe that, I believe that our variable has some sort of trait. So I keep it 3 as it is. Then I click on the OK, and it is the outcome of the vector error correction model, you can see, and it has two cointegrating equation. It is number 1 and it is number 2, right? It is number 1, it is number 2. So we have two cointegrated equation in the whole system, in the whole vector error correction estimates.